When you think of AutoCAD, what's the first thing that comes to mind? Is it 3D modeling, 2D drafting, or could AutoCAD be used to teach mathematics? That's exactly what we'll demonstrate today. How AutoCAD can help visualize the construction of an ellipse. Let's get started. For our task, we will need to create a few layers. On the A-axis layer, we'll draw a circle with its center at 0, 0 and a radius of, let's say, 100. Here it is, our first circle. Next, on the B-axis layer, we'll draw another circle, also at 0, 0, this time with a radius of 60 millimeters. So, what exactly is an ellipse? Visually, it's a closed curve looping around these points. But how do we construct it mathematically? It is actually surprisingly simple. Watch this. On the radius layer, we'll draw a line starting at 0, 0 and place the other endpoint arbitrarily. Now, if we project the intersection of this line with the yellow circle down to the x-axis, and the intersection with the red circle across to the y-axis. Where these projections meet, that's a point on the ellipse. To make this work dynamically, let's add some helpers. Back on the A-axis layer, we'll draw a vertical line. Press F8 to lock it vertically. On the B-axis layer, we'll draw a horizontal line. Again, press F8 to lock it horizontally. Now comes the parametric magic. Go to Parametric and apply the fixed constraint to both circles so they cannot move. Fix the starting point of the radius line as well, so the line can rotate around its origin. Next, let's constrain this line vertically. Choose vertical, then select the object. Do the same with the horizontal line. Choose horizontal and apply it to fix it. We want the center of our vertical line to always lie exactly on the radius line and also on the yellow circle. How do we do that? Apply a coincident constraint. First, select the center point. Then the radius line. But before we do that with a circle, let's lock dimensions. From the Dimensional tab, apply a radius to the yellow circle. And again to the red circle. These are parameters we can later change to generate different ellipse shapes. Now we apply another coincident constraint between the center and the yellow circle. What happens? As we rotate the radius line, the projection on the x-axis moves dynamically. We'll repeat the process for the horizontal projection on the y-axis. Again, apply a coincident constraint, select the point, then the objects. And now, look at this. We have an intersection point moving smoothly depending on the position of the radius line. To make things clearer, let's add a reference line on the ref layer. It starts at the center, and we'll press F8 to set it horizontal. Now we'll set the angle between this reference line and the radius line. The reference line stays fixed horizontally, while the angle parameter can be changed. Let's try it. We set the angle to 30 degrees, and immediately a new intersection appears. And here's the big reveal. Let's check if we've really got an ellipse. Select the Ellipse tool. Pick the two defining points. Select Quadrant. The intersection of the projection lines lies exactly on the ellipse. As we change the angle, the point moves perfectly along the curve. AutoCAD can do more than create technical drawings. Can bring mathematics to life. Visual, interactive, and easy to understand.